All right, so we're going to start by looking at page 97, and there's this part here in a box. It's a division property. So we're going to kind of pick this apart. So what it's saying is when we have a radical that's a fraction, okay, with an index of n, we can separate that. We can make the whole top, maybe I shouldn't do that. We can separate it. So we can have the top of the fraction inside the radical as its own radical, and we can have the bottom of a radical as its own radical. And then what's this saying is n, which is the index, it belongs, so this right here, this means n belongs to the natural numbers. And again, natural numbers are numbers you can count out in nature. So they start at 1, 2, 3, etc. No decimals, no fractions, can't be 0. And then we say a and b. These are represented either as variables themselves, or they can be any number we want, because it says a and b belong to the real numbers. Okay, and so that basically means a and b can be anything as long as b is not 0, because then we're getting a case where we're dividing by 0, and you just can't do that. It's not allowed. So we're going to use this property in order to look at example 2. So what this is asking us to do, so it says check your understanding on page 97. This is asking us to write this radical as a mixed radical. So what does that mean? It means we're going to have some numbers on the outside, on the inside. So again, you were probably taught this. Well, I know for a fact you're taught this a different way than I do it. I'm going to show you the way I do it. So what I'm going to do is I'm going to prime factor my numbers. And here's what I mean by that. I'm going to take 16, and I want any two numbers I can think of that multiply to give me 16. So I'm just going to pick 4 and 4. Okay. And then I stop doing this type of tree when I hit a prime number. Okay. So in the classroom, there's some prime numbers on the board written in purple. If you're not sure what prime numbers are, I can go over that with you. So again, 4 is not a prime number. So I want two numbers that multiply together to give me 4, which is 2 and 2. And similar for the other 4. So what that means is 16 can be written as, let me say this again, 16 can be written as 2 times 2 times 2 times 2. So we're going to do the same prime factoring with our second number, which is 135. So I want two numbers that multiply together to give me 135. So I'm not an expert at my 135 times table, okay? So, but I know any number that ends in 5 or 0 is divisible by 5. So if I take 135 and I divide it by 5, I get 27. So 5 is a prime number, so I don't need to prime factor that. 27 is not prime, so I need two numbers that multiply to give me 27. I know 9 and 3, okay? 9 is not prime, because 3 times 3 equal 9, okay? But 3 is prime, so I'm going to stop there. So here's what we're going to do. Using the property we just looked at on the previous screen, or this one in the box right here, okay, we're going to write this as a slightly different looking fraction. So I'm going to have the third root of negative 16 over the third root of 135. So what we've done here is we've prime factored these numbers. So in order to be able to move some numbers to the outside of my radical, I need to circle my prime factors in groups of this number. So groups of 3. So what I'm going to do is I'm going to circle 3 of my 2's here. Okay, I only have 1 2 left, so I can't circle that with any other 2's. And then I notice I have 3 3's here. Okay, but I only have 1 5, so I just leave it. So what happens here is the number that I circled, it can be represented on the outside of the radical, and then it's represented on the outside of the radical once. So these 3 2's that I circled are represented on the outside of the radical once. Okay, and I still have a 3, and now whatever's left, what I haven't circled, stays on the inside of the radical. So we have the negative there. Okay, and then similar for 135, well, I circled a group of 3's, so they're represented on the outside by one of the 3's, and then whatever is left, I stay inside the radical, which is that 5. Okay, so technically that's a pretty good answer. We're gonna clean it up a little bit. Um, way back in one of the tutorials, I had said that it's okay to take the third root of a negative number. That's okay. So we're going to take that negative outside. Okay, so again, we can only take that negative outside when our index is an odd number. Okay, so this, it will become -2. It will become like that. Okay, and then doing the inverse of our property. So what we had done is we had used our property, whoops, sorry. We had used our property, let me try this third time lucky, here we go, to go this way. But now to answer our final question here, we're going to use this property. I just got to wait for this to disappear. There we go. We're going to use the property back the other way. So we're going to use it back this way. So this will finally become, so I can have that as a fraction, and then we'll have something like this. Okay, so if you get this and you're like, well, how did you do that? You can ask me. What I've circled here in black, that is a perfectly good answer. So if that's as far as you got, let's stick with that. Okay, and then we're going to do B. So B is the -3 and then the fourth root of 2/27. And then they want this as an entire radical. So again, what that means is I'm going to put -3 back inside my radical, okay? Because my index is 4, I need to multiply -3 times itself 4 times. So when we do that, when we change, when we're moving something onto the inside, okay, and we have a fraction, that means, sorry, the bell's ringing. That means we're going to multiply our -3 times the top number. So here's what this is going to look like. So we're going to have the fourth root of -3. Oops, let's not even do it that way. We have the fourth root of 2, and then we're going to have times -3 times -3 times -3 times -3. And that's all going to be over 27. So let's make that radical huge. Okay, so if we do that, so let's do this. So 2 times -3. Since I have 4 -3s, I can just call that -3 to the power of 4. That means the same thing. And when I do that, I get 162. So this becomes 162 over 27. So if I math 1 that, so we're going to do 162 divided by 27. We math 1 that. We get 6. Now, is that the same answer they got? Okay. It is, but it isn't. So I've made a bit of a mistake. Let's go over what I did wrong here. Okay. We have to be really careful with our negatives and our indices here, our index. So notice here, I've circled this 4. I wish I did it in the magic pen. So I circled the 4 here. Okay, because that's a 4, that means this negative needs to stay on the outside. So what I was really doing here, I would re-record this, but I think it's good to learn from our mistakes. So I'm hoping you wrote in pencil. So we're leaving the negative on the outside and we're just multiplying by 3's. Okay, we could have brought the negative onto the inside if our index here, okay, was an odd number. But since it's even, it kind of ruins things. So we still need, let's rewrite this a bit. So we still need the negative on the outside, okay? And so our answer will always have a negative on the outside. Okay, so that is done. You can move on to the next tutorial.